This gives you a distribution of the types of projects that students in the class have selected, and this is by category. You'll have an opportunity, if you want it, if you're interested in, to look at that in more detail when you see the presentation on the web. And by also gender, male and female. Blue is male, pink is female. I gave my graduate student to do this. So I just realized it a couple of, just before I left, so I apologize for this. It was not intentional. Anyway, so this, you can see the spread in terms of their interests. Obviously, there are topics in automotive, but you will see quite a lot of electronics, quite a lot in gaming, household items, office wear, and mind you, this is a population across disciplines. I have for mechanical engineering as well, so you'll see that in a little bit. What this shows you is a distribution of the choices on a per discipline basis. And you will see again, different on the horizontal, different areas. Blue is the color for mechanical engineering, and you see it ranges from cell phones, automotive obviously is there, sound devices, quite a lot of, and so on and so forth. But it also, I think that it helps quite a bit in terms of looking at also what other disciplines have chosen. And then moving on to now, by the way, the population of relating to the data that I showed you before were about 290 students. And what you're seeing here is basically by major, the breakdown in terms of numbers of students that were participating in that study. Okay, mechanical engineers obviously is quite a bit, and undecideds, and everything in between that were taking the class. Breakdown again between males and females. This slide here shows you breakdown in terms of choices of particular topics in terms of males and females within the mechanical engineering discipline. Again, you will see distributions that maybe at some instances you would not expect. There was a discussion earlier, there were some people talking earlier about the gap between the generational gaps between us and our students, what interests us and what interests the students. I think that that is something that we ought to look into or take into consideration. And this is just, these are some snapshots of the examples that they chose on their own to look at and what they have done with them. You see all sorts of different things. It's just a sample. And what I've done is I've went a little further and I've given you, remember, we asked them to just simply model something. And some people went far more beyond that to even introduce animations into, and I'm going to try to get them to work here. Oops, I'm having difficulty here. Okay. This is all a sample of student work. From a rice cooker to a fixture, and there are many in between. There are projects where people looked at Puma shoes. There are projects where people looked at or worked on lacrosse equipment, and so on and so forth. I'm just giving you some samples of the kind of work that they have done. Now, do you think that they were interested in doing this sort of thing, or do you think that they felt that this was a drag for them? Well, we actually ran a survey before, because we had data before we made the change, and after, and here is here are the results. What it shows in red is the original syllabus, where we had not introduced complex shapes and modeling using modeling techniques for that, and also we had not introduced the project. And the one in blue is basically the introduction of the project. Let me remind you that that has a lot to do with the second half of the course, and you can see the difference between them in terms of student interest and in terms of what is going on there. So, what have we learned? We've learned that yes, the student interest is pretty high, is maintained throughout the course, and also that they go even beyond what we asked them. The challenge still remains in terms of how do we introduce all of, or incorporate all of the principles that in a graphics course one would want to do. So now, I want to continue on now into the other aspect. That was the second, I'm going to talk about the second gear in our integrated effort to give them an experience in engineering, an introduction to engineering. This is what we call it is experiences. We run this throughout the first and second semester, where they have to gather a total of 9 experiences through the period. So what you can look at, and I might as well just give you the slide, which describes what we were doing before and what we're doing now. It was in 1 credit freshman seminar, we used to call it, and I'm sure that some of you have it as well, where basically 20 to 24 students met 1 hour a week informally with a faculty member. They discussed engineering, careers, academic and personal success strategies, curriculum, as well as ethics. What basically we saw through that experience was that, you know, it could start strong, but then people would grow disinterested, and we were told by the students that they wanted to have more choices. So we replaced this by this 2-semester engineering experience, and basically focused on giving them choices. But at the same time, we have some required experiences that they all have to take. And examples of that would be a lecture on impact on globalization, engineering ethics, as well as library orientation. All is run through this experience, through the web. The students sign up for the individual experiences. They know when they are offered, and so on and so forth. Now, through the mechanical engineering department, what is it that we are offering? I'm going to briefly talk about 2 of them. One relates to what I call product engineering, because as mechanical engineers, what we do is really product engineering. So we have an experience where we take them through product re-engineering, product design, product manufacture, and product testing, and we pick several examples that they use in the process. I'm going to show you one, and we have others, a library of those that they basically pick. They select the project out of the choices that we are giving them. The one that I have is basically a pump, which would go through, as I said, first they do a dissection, product dissection study, then they plan out. This is happening over a 4-week period, 4 afternoons that they carry this out. Product dissection, they're planning out the rest of their activities. They go through a design activity for it. They go through prototyping, modeling, fabricating, prototype fabrication, as well as assembly and testing. We do give them spreadsheets with the information that they need. So you could look at then the kind of effort that is going on in here on the product dissection, and they do sketching. Remember, this runs in parallel with the graphics, so they have done sketching in there. And this obviously, because they're going to use that in cutting gears, so we give them spreadsheets that they can calculate tooth profiles for themselves. Also, what is important is they identify what is the required input and output for the particular one, so that they can focus on their model on inputs and outputs for the system, as opposed to just simply running all over the place trying to determine what to do.